so I'll wait for everybody to kind of settle down. Apparently they're going to steal lined paper from other people.
Yeah.
At least it's on camera.
Oh, hey.
Hey,
that's recording the board.
Don't point that camera.
Just so you know, look.
I didn't point that camera at you.
You have to ask.
Don't they take pictures? I already did.
No, you didn't.
You signed a syllabus and said it was okay a long time ago.
That was my real signature.
Too bad. Counts as.
Caitlin Hurst to room 205, please. Caitlin Hurst to room 205.
Pretty sure you're lying.
You can't lie.
So first question. What is meant by the term concentration in terms of molarity? Concentration or molarity?
Over this.
In chem, I've never heard it.
Okay, so molarity is actually moles per liter. We did this at the very beginning of the quarter. We did a molarity worksheet. I stood in the back of the
This
room.
isn't a midterm. Why is this?
We haven't had a test the entire quarter.
We don't need one.
You don't have to take it.
Okay.
What happens if we don't?
I suppose you would probably get a 0, yes.
Then train your grade.
So, units of molarity, yay. Concentration, what? I had these lovely little jars up here that were 2 different colors.
They're blue.
One of them was a lot darker than the other. What is meant by the term concentration?
More grams per mole. I don't know.
Maybe if we're using the units.
Mole per liter.
Yeah.
More moles per liter?
Yeah.
So, for example, my orange juice concentrate is more concentrated than my orange juice.
Yep.
Okay, I'm happy with that.
Yeah.
Just know that the reason these things are up here is because they might be on the test.
Or what?
So, if there are any questions on the term concentration, now would be the time to ask.
I have a question.
Question?
What is concentration? What is meant by
How
the
much
term
stuff?
concentration?
How much stuff is in a solution?
How much stuff is in a solution?
For our purposes, in terms of molarity,
What's a more
it's
scientific word for
how many
stuff?
moles. In terms of molarity, how many moles are in a liter? So if we have 100 grams of sodium nitrate in 500 milliliters, what's the molarity? First of all, my question is, what are the units of molarity again?
At moles per liter.
Okay, so we're trying to get to moles per liter. So when we see grams, this is what we've been working on. When we see grams, what do we have to do?
Convert it to moles.
Yay! Alright, I can do that pretty quick because I've got 100 grams. I know. Should I put grams on top or bottom?
Top.
Do it on top.
Bottom.
Bottom.
Okay. I just had to step out of the way so you guys could see what I was doing.
Yep.
Yeah, it wasn't really fair
So
to
then
us.
this is our mass of 1 mole of sodium nitrate. So 100 divided by 85, anybody?
No.
Oh.
Don't know that.
Do you want me to get my calculator?
I got it. Oops. Make sure I don't want to round it too soon. Okay. So this is how many moles we have. So if that's how many moles we have, and you said it's moles per liter, what do I have to do now? This is like, if we consider this step 1, what's step 2?
Put it over liters.
Stuff for some.
But I have milliliters.
Put it over 1,000.
0.5 liters. Okay, so now how do we get moles per liter?
Okay.
Moles per liter?
Yeah.
You're going to take 1.18 and divide it by 0.5.
I'll just do that right here. So then our answer is, by my calculator, our molarity is 2.35 moles. Molarity, excuse me.
I don't know what just happened.
Where'd you
I
just
know.
get those numbers?
These are some thought questions for you guys in terms of kinetic molecular theory. You've answered this before in a worksheet. Why is there a warning on aerosol cans that tell you not to leave the can above 120 Fahrenheit? Bryce?
Because it gets dangerous how fast the things are flying inside.
Maybe a little more specific.
Particles are colliding inside.
Okay, so we're going kinetic molecular theory here. Somebody's saying that if the temperature increases, the speed of the particles increases,
Which rockets off the side.
which creates more collisions, right?
Right.
Yeah, more collisions.
Then it
Okay, so if there's more collisions at a higher temperature, you're putting a lot of pressure on that container. And so the faster they're moving, the more collisions there are. There's a reason why you can't have it above a certain temperature. Question or comment? Okay.
Is
I'll
that
step
why
aside.
you can't like put an Axe bottle in fire because it blows up?
Yeah, that's the same thing. Like when containers, I have got my static guard here.
That's disgusting.
It says, do not expose to heat or store at temperatures above 129 Fahrenheit, 49 Celsius, as can may burst. Do not puncture, incinerate, or crush. So, because if you puncture it, you're releasing the pressure the wrong way. Like this. See, this is.
Why are you spraying it at me?
It's broken.
What is it anyway?
It prevents like static cling.
Oh,
on the
that's
clothes.
Put that on
So
yourself?
yeah. So
Can you
you.
please not point that to me? I feel very.
It's broken.
Isn't that what a dryer sheet's for?
How do I trust
Yeah,
you?
but then like if you wear like a puffy jacket like I do, it like immediately all the static's back. So do not puncture, incinerate, or whatever. This is how it's supposed to leave the container, right?
Puncture it.
So it has a high pressure in here. So if I puncture it, that's a really good way to lose an eye, because all that gas comes out of that hole really quickly.
Can you spray it on yourself?
Does it smell?
I don't need to.
Just do it, please.
Does it smell?
Creep.
Does it smell?
Oh crap.
What?
Alright. Question number 2. What property of gas is measured by temperature?
Yeah, you're gonna be able to bring it. I'm just scroll down now.
The property of gas is measured by temperature.
What do you mean by
Speed.
puncture?
Speed, close. No, it's okay.
Density.
No.
You mean like boils and...
No.
No, that's not.
There were 5 postulates, one of which
Oh.
talks about their kinetic energy.
The first one.
Pressure.
Kinetic. Oh, kinetic energy.
So I had an equation talking about average kinetic energy, where kinetic energy is equal to half the mass and volume, blah, blah, blah. But most importantly, you need to know that kinetic energy is directly related to temperature. So if they have a higher kinetic energy, they have a higher temperature. Okay, question number 3 for kinetic nuclear theory. Why does pressure go up when the volume goes down? I'll draw a picture. I'm drawing a picture.
Well, I
You draw that picture.
because like it has less space or less or greater space to.
Volume goes down, so less space, yes.
So it has less space, which means it collides more.
So
Creating
our
more
little
pressure
particles.
on the walls
Oops.
of the container.
There's more space.
If we step
Less
to the
space.
right
I said
after
what
you're
happens when when volume goes down. So there's less space for them to be like bouncing
More
around.
collisions.
So there are more collisions. So more collisions, which means what?
High
More
pressure.
pressure.
Higher pressure. Excellent. Questions on that?
No, ma'am.
Okay.
On the test, are we gonna have the equations given to us?
You're gonna only need to know the same 2 as last time. Combined gas law and ideal gas law. You have to know those.
Are we gonna get the conversions on the test?
Yes.
Or do we? Okay.
All except for 2.
And like conversions, like ATM to KVA.
Oh, yeah.
Yes.
I dear hope so. Is this gonna be a lecture? Or is this...
No, I'm recording it so that people know I did it.
We need attention
No
tomorrow.
What?
I just
No.
want attention tomorrow.
Nope. That's what I say that late.
How are you... Wait, what do you mean like, recording it?
So I can have it.
Sound?
Yeah. In the video.
Oh my
Wait,
god.
so you're not posting it as a lecture?
I'll do whatever I want with it.
Okay. It's not gonna be homework, right?
No, it's not gonna be homework.
Well, you're already here, so.
True.
Okay, so I did a little conversion for you guys. Math.
Okay.
Alright, so math on this. V1, P1, so we got 1 atmosphere times 6 liters equals 0.83 atmospheres times V2. Solving, 6 divided by 0.83. Is the volume going to go up or down?
Down. Up.
If pressure goes down, volume goes up. So our new volume should
Go up.
be higher.
Go
And my calculator says it is
12.
7.2. That'd be a lot bigger. That'd be
Yeah.
like scary bigger.
It's like double.
Well, and the pressure didn't double, right? The pressure didn't get half as big, so. Okay? So, a simple problem dealing with Boyle's law and lung capacity. Okay, write it down, solve it. Be right back.
Not done yet.
All
We
right,
need to convert that to Kelvin.
Yeah.
All right, we got Charles' law.
Always.
V.
Kelvin!
Wait, do we need to convert it to
Kelvin!
Kelvin?
Kelvin!
Kelvin!
Yes.
Yes.
Alright, so that's 295 Kelvin.
It's 23.4.
Oops.
That doesn't make sense. Got it.
Yeah.
No, I think his school seems better than Spares. White Sox is the Bears guy. So there's
Oh, wait, 295, did I hear?
295, yeah.
All right, so I'll write it out as you guys are. So we got 2 liters over 295 Kelvin equals question volume over 271. So my question before we answer this problem is, temperature goes down, what happens to volume?
No, it goes down.
Temperature. So temperature goes down. The average kinetic energy of the particles goes down. So they slow down.
Right.
They don't hit that wall as much. So what happens to the volume?
Goes down.
So it goes down. So our volume
Should go down.
should go down.
What happens
And
if
then the
you-
question is, does it? I'm gonna cross multiply. Bam, bam. 2 times 271 divided by 295, and I get a volume of 1.84 liters.
We're good.
Everybody agree with that?
Yep.
Looks good. Questions?
Yeah, I agree.
I got that one.
Oh, okay. You guys can handle this one. I'll write out my method of solving.
Can you write out the equation?
I did. It's up.
Oh.
Up right.
Oh, we just did one of these.
No, we didn't.
We did one with
We
pressure
did.
and pressure.
Charlie's
and volume
law.
temperature.
Charlie.
Ouch, Charlie.
Charles. Pressure 1. Ooh, 84. I'm gonna divide that.
Can you use KPA?
You can. Ooh, I like that idea actually.
No, I don't like that idea.
No, I do.
Sorry if
No, I definitely do because we're talking 84 kPa here
Well, what if
and
you
1
do-
atmosphere here.
Yeah, like
It's going to be a way easier conversion to just say 101.3 kPa.
well, what if you're already
You get the same answer. As long as you're talking about, as long as your units are in the same, as long as your temperature's in the same unit and pressure's in the same unit, you'll be fine. So we're looking for a new temperature. Pressure 1. I always write my units down so I don't get confused. New temperature, don't know it.
No.
New pressure, you know it. Okay.
How did you convert 1 ATM to PA?
I just know that 1 AM is equal to 101.3 kPa.
So should we
Which you would
memorize
not,
that?
no, you would not have to know that.
So we're not going to have KPA on the test?
You might, but I'll tell you what it's
Oh,
equal to
okay.
if you have to convert. Let's see, 333 times 101.3 equals divided by 84. So pressure went up,
Yep.
so temperature
Goes up.
also goes up.
Yep.
So let's see it. Nice. Our new temperature, magically, much hotter.
401.
We'll call it 401. Well, no, 402, really, for rounding.
Three suffix. Deep sea diving in Guatemala.
All right. What do you think I'm gonna ask on this problem?
So you have
We gotta find the number of moles.
No.
No.
we're
What the
doing
air
combined
pressure
gas
is.
law.
okay, wait. you
Pressure.
No.
No? It's gonna be,
Combined gas law
temperature. No.
means we're talking about a change.
Volume.
We need. So I'm looking for the new volume.
We didn't have a volume.
Score.
Yes, you did.
Sorry.
You should be.
What about moles? Do you just do a
Did I mention moles?
No.
You don't need it.
So what does that mean?
It means one.
There.
It means
Is there-
1. It means I can ignore it. I can just take this out altogether.
So is
That's
that the
the
same,
easiest.
like, say we didn't have temperature?
We
Is
would-
that the same?
We had temperature.
No, say we didn't have temperature.
If
but
it
we
was
had
never
moles
mentioned?
Yeah, but we had moles instead. There's somebody here.
Okay.
You're using the set
she
temperature,
took
like
off.
the 760 or whatever.
You're yelling again.
Sorry.
your question is if I don't ever mention temperature,
Yeah,
Just
so
say
you put in
273.
moles instead.
then you could use 273 on both sides, or you could just ignore temperature and not include it.
Okay.
Like combined gas law is really good for manipulating gas problems of any kind. If you don't know for sure that you need to use Boyle's, gay-lussac, or Charles, plug the numbers into combined gas law
Okay.
and see what you have. Okay, so I'll do that while you guys are writing this down. Ooh, do I have to convert this to atmospheres?
Yes.
No.
I say
Yes.
no.
No, the only time you have to convert to atmospheres is to
Tip nerd.
Tip nerd.
Tip nerd. Alright. So I asked you guys a question a little while ago. What has more influence on volume, temperature or pressure? Temperature
Yeah, pressure.
is definitely pressure. Okay? If there's less pressure being exerted on something, it's way more influential than a temperature change. Because if you look at these numbers, 238 to 348 is not a huge temperature drop, but 688 to 400, that's a big change in pressure. So my guess, based on my knowledge, is that the volume's going to go up. Even though, let's see, we got pressure goes down, so volume goes up, right?
Yep.
We also have temperature goes down, so volume should go down, right?
Yeah.
But I'm going to say that pressure has more of an influence, and we'll see what we get. I'll plug these. Somebody plug the numbers in while I write them up here. So we got 688 times, oops, that should be 3. Now, does anybody need me to like walk them through the math on this, or can I do it quickly and not? Because I'm going to do weird cross multiply. I'm going to do 688 times 4.33 times 238 divided by 400 divided by 348.
Whoa.
Go ahead.
That's all I'm doing is getting V2 by itself.
Well,
the
how do
other
you get
thing,
V2 by itself?
The thing
So-
is, I'm getting like huge numbers.
Okay,
when I
well,
do
we'll
this.
see. So the other thing you can do is to write the equation first, rearranged. So to get V2 by itself, we're going to do P1 V1 over P2 T1 equals, oops,
You messed up.
oh yeah,
There's no.
no, I just got to put T up here.
This is like this is very wrong. I got like
a small number.
one.
Alright, I'll plug numbers in and see what happens.
Oh gosh.
What'd you do?
Not that time, Grace.
That's okay. I'm just gonna see.
My new volume is 5.1. Anybody get that?
Yeah.
Well, but the thing is, you guys can take the equation.
Is that 5.1?
Oh, why does it do this to me?
Got
I don't know.
5.09.
So you guys can take the equation and plug the numbers in and leave a part of it blank, like I did up here. Or you guys can rearrange it so that the thing you're looking for is by itself, and then plug the numbers in. Like there's two different ways you can go about it. I have been doing it the first way because that's how everybody else does it around here. But my way, like that's close to my heart, is rearranging the equation first. So it's whichever you're comfortable with. But was I right? Did the volume go up?
Yep.
Yay!
Very little, but
A little.
it went up.
But the temperature went down too, so there's a little push-pull there of which thing is stronger.
And the answer is.
I had 5.1. Key phrase in an ideal gas law / Dalton's law problem. If you see that I wrote a question, like, let's see, I'll find one right in here. I got one in the review thing. 0.52 grams of an unknown gas is collected over water. So if you see collected over water, we got to subtract out the partial pressure, which is, so Dalton's law, total pressure is equal to the sum of all the gases, the pressure of all the gases.
that's
in the
Dalton's law?
container. This is
P
Dalton's
total?
law. Okay. In our case, like this is how it's written in one of your worksheets, but in our case, we're really only worried about the pressure of the gas we want and the pressure of water. Okay, this is really all you're ever going to be worried about. Somebody's going to look on the water vapor chart back there. 75.0 degrees. What is the pressure of water?
289.1.
Wait, what's collected over water?
289.1?
Yep.
collected over water, we're talking, so when we're doing ideal gas law, we're looking at a gas being collected, right? Like we're producing a gas. Like we've done, all of these labs we've done is we've been collecting gases. And we've been collecting them over water. And so when I'm just writing this down so that you know this key phrase, if you see it in the test, you know that you've got to do Dalton's law first. Okay? So we're collecting gases. We can't do like a pressure problem, any kind of problem, if we don't subtract out the water vapor pressure too. Okay? Let's just go with 760. Just for that.
Perfect number.
Holy.
Now we're trying to find volume. I apologize. What's R, by the way?
0.08.
Point zero. Oops.
0.
8206 L ATM over N
Liters, atmospheres,
over NK.
moles.
Okay.
I know what you mean though. Kelvin. Okay. 289.1. What are the units on this?
We allowed
On
to
that
use
water
these
vapor
notes?
pressure chart that you have to use. What are the units?
Oh, mole.
No, we're talking pressure.
Degrees Celsius.
No. That's temperature. Talking in terms of pressure, is it KPA, atmospheres, liter, or
ATM.
what? What? It's not atmospheres.
I'm gonna go with
That's-
MMHGs.
And then.
PSIs.
I'm gonna go with what you said before you said PSIs. So
Are we gonna be allowed to use our vapor pressure sheet on the test or
yes,
not?
absolutely.
Okay, cool.
That's insane. No, you have to memorize all the numbers on that.
Oh my gosh. That'll be.
Okay, so now we're
So
trying to
funny.
find volume. But what do we have to do first? Now that we've gotten this problem worked out,
Organize it all.
see, this is we just built a problem all together. Bryce, what do we have to do first so that we can get the pressure of the gas we're trying to collect, right? So I'll just write it right here. 760. Somebody do the math for me on a calculator. 760 minus 289.1. Oh,
470.9.
okay.
Wait, why is it minus?
Because this is the equation for Dalton's law.
I thought it was
So-
plus though.
No, well, yes. So let me show you. The total pressure of a container is equal to the sum of the gases in it. So what we're trying to do is solve for A. So if I'm solving for A,
Ew.
Do you
'cause
see
we're
what I
taking
did?
the H2 out.
so
yeah,
I'm taking
yeah.
H2O from the total. So I just rearranged it. So this is P total minus PH2O equals pressure of A. Okay.
Yeah, got it.
So with that, while you guys are scratching this down, we're solving for V. So again, you have two options. You plug in the numbers and then rearrange, or you rearrange and then solve. So I'm going to rearrange because that's my style. Question.
So we need to make the atmospheres though.
Ooh.
Pressure.
Nice. Okay. So I'm rearranging. Volume. Where's what we're trying to solve for, right? On this
Right.
one. N. What's N?
Number of moles.
And that's 102 moles. What's R?
Point
Is it-
0.8206.
6. I won't write the units this time. Temperature. Did anybody do it?
It's 348 Kelvin.
Okay. What's pressure? The pressure is 1 atmosphere.
1 atmosphere.
No, it's not.
No.
Oh, for the
Is that
regular
four-
one.
What's the
four
pressure that
11?
we're using for the gas that we're trying to find?
Oh.
Yeah, that.
Assume that we are trying to find gas A. Okay, so P of A is A, gas A. So what's the pressure that we're working with?
Oh, 470.
470.9 millimeters mercury. But do we put that into PivNert?
62.
Do we put that into
No.
PivNert?
No.
We're using a
Okay.
0.62.
So alright, so for the sake of maths, I'm going to divide this number by 760 to get atmospheres, which I get 0.62. Alright, let me do the math here. 0.102, 0.08206 times 348 divided by 0.62. I get a volume of 4.7 liters. Now why is it liters and not milliliters?
Volume is in liters. Oh, because of cancellation.
Because in PivNert, everything cancels. Moles, moles, Kelvin, Kelvin, atmospheres, atmospheres, liters. leaving liters because R is in terms of liters, atmospheres, moles, Kelvin. Which equation of all the gas laws we use do you have to convert to those four things? This one. Okay. Questions? Do I need to leave it up for a minute?
Yeah.
Molar mass, also known as formula weight,
Don't you want to warm up?
also known as grams per mole. Okay? So, when we're doing a problem, now when I'm looking for the molar mass of a gas, almost 100% of the time it's going to be Pivnert. Okay, so from now on, Pivnert. Okay, we're going to be talking about pressure, volume, R, N, and temperature. Okay, I've got a problem here. It happens to be number 1 on the worksheet, 8.9. So I'm not going to write everything down from the question. I'm just going to write down the information I have. And I know that number of moles is also equal to grams over formula weight. Okay, so what I can do is rearrange Pivnert. I'm going to do it a couple steps. You guys can see it. I'm going to replace N with grams over formula weight. And then the question's asking what's the molar mass. So I've got to rearrange. I'm just going to do it in one step. I'm going to rearrange to solve for formula weight. Okay, you guys have seen this a couple times before, right?
No way.
So let me give you the information. Okay, so we're solving for formula weight.
How many seconds do you want us to go for pressure?
I would not worry about
She
it.
doesn't care about safe things.
Yeah, I really don't.
Should
Not
we
as
convert that
much
to
as I should.
liters?
What? What was your question?
Milliliters? Should we convert that to liters?
Ask the group.
Yes.
Yes.
They will say yes.
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 Hank,
Because of
yes,
this.
Hank, yes.
Does everybody's equation look like this?
Wait.
Yes.
Hopefully.
Yes.
My question is what cancels?
Okay.
Just tell me what to cross out.
ATM.
Liters.
ATM for sure.
Liters.
Liters for sure.
Can you take
Kelvin.
easy? I can't.
Kelvin for sure.
7 grams per moles.
Yeah, that's it.
There are no moles on the bottom.
Grams per mole can't cancel, but isn't that what we're looking for?
No way.
Oh my
Excuse me.
God.
Plugging in the math, doing all the math, we should find something with a formula weight of blank grams per mole based on all these cancellations. Know this on your test on Friday
No.
or Thursday, whenever it is. If you don't show me these units, I will take points off.
You won't. Wait.
Yes, I will. I did on the quiz.
Like legit? No
Legit.
way.
Whatever
Legit?
that means.
No, but
I
the
assume
thing
that
is-
means truth.
the
So
thing is,
yes.
though,
I get a pretty big grams per mole for a formula weight. Does anybody want to share the number?
841.
Yeah, I got the same. We'll call it 841. Okay?
My goodness gracious.
With that, I'll leave it up for a moment. And then we're going to move on to the last stoichiometry problem. And I'm out of here.
The stoichiometry I've given up.
Okay, stay with me.
Don't give up, Julie.
So here's our problem.
It's already happened.
Copper 2 oxide reacts with carbon to make solid copper and carbon dioxide gas.
Excuse me.
34.5 milliliters carbon dioxide is collected over water at 655 millimeters mercury and 32 Celsius.
Are you?
How many grams copper oxide reacted?
First, we need to make a balanced equation, right?
Oh, great call.
Well, I mean, when I look at a problem like this, I see volume, temperature, and pressure. And so I think to myself, okay, and there's no change, so probably going to use Pivnert. Okay? I mean, one can assume that if there's no change, it has to be Pivnert.
It
Okay.
has to be.
So first off, we're talking Pivnert. Before we talk about anything else,
I haven't even finished writing down the problem.
it's okay.
Wait, what if we had to cross out Pivnert?
What?
Are we gonna have to use Pivnert?
Yeah.
Okay, cool.
Ooh.
That's easy.
All right, I'll wait a little bit for you guys to write this stuff down. So
Could you please
I
move?
see information that tells me we're going to use Pivnert, but I also see information that tells us we're going to need a balanced equation.
I forget how to do balance equations.
It's okay. You maybe need some
They're
practice.
fun.
if you like them, or if you don't like them, they're not fun.
It's kind of strange
They're
how I
just
like the
torture.
balance equations.
Wait, what is 655 millimeters of?
Mercury, that's pressure.
Yeah, but what's that in ATM?
Divide by 760. Okay, so first step, balance equation. I'm gonna give you guys the equation, but I'm not gonna balance it. I know copper oxide reacts with carbon to make copper and CO2. This actually looks like a pretty simple equation to balance. We got, Juliet knows, we've got one oxygen on this side and two oxygens on the other side. So
we
Juliet.
have to put it in front of the CO2. And
What?
Then,
Looking at the same thing?
The CuO.
What do I put in here?
A 2.
Okay, I
And then
agree.
you have to put a 2 in front of the Cu.
I can do that.
Look at me go.
Look at her.
Look at her.
Right? Okay. Balanced. Done. Yay. Now,
Tell me this. Is it going to be that easy on the quiz? I mean, test, excuse me.
I mean, it's not easy, hard. I don't know. I don't know what to tell you.
Is
The equation.
Yes. The equation.
I'll give you enough information to get the equation. The balancing part is on you.
So if I come up to
So it
you
might
and
not
be
be super easy.
is this right for balance? Like,
I would always tell you.
okay.
Wait, what's the original equation?
It was CuO plus C makes Cu and CO2.
Yeah.
We just added 2's in there. Okay, so we gotta use Pivnert. What are we using Pivnert to find?
Moles.
How many grams of
No. Like what gas are we talking about?
CO. Copper oxide.
That's not a gas.
Carbon dioxide. These are going to be on the test.
At least 2.
Oh my freaking god.
You're that bad.
Hence why I'm trying to help. All right, carbon dioxide gas. What we're talking about? What do we know about carbon dioxide gas? We can fill in here.
It's grams per. It's molecular weight.
That doesn't go in Pivnert though.
Oh.
What can we put in Pivnert?
Pressure, volume.
Diagram volume.
0, 3, 4, 5. What is it cool
Temperature?
if we use
Do we have
0.
temperature?
305 Kelvin.
305.
And pressure is 0.862 atm.
Got that. What is it?
0.862 atm.
I'll call it 86. Okay. So, what can we do with Pivnert?
Thank you.
Solve for, say it, N, which is
N equals
number of moles.
RT over PD.
That too.
What
That's
is it,
what it
PV
should be
over
PV
RT?
over RT. Yeah, that's what I meant. Okay, let's do a different color. I'm not going to write the units to save myself some space. What's going to cancel out? What are my units going to be for this answer?
Moles.
Moles. Okay, I'm just saving space. I'm not encouraging you to do this. I'm just trying to save some space. So 0.86 times volume over R times temperature. Anybody get a number? I can do it. I do the same. I'm going to call it 0012. Now, is everybody following along so far?
Yeah.
What have I solved for?
Moles.
Of what?
CO2.
Moles of CO2.
We need to find
Whoops,
grams.
too many ones. What do I need to find?
Copper oxide.
What about it?
Grams of copper oxide.
Okay, I like that. So I'm trying to find Stop. Trying to talk. Trying to find grams of copper oxide, but in terms of grams and moles, what do I know? What's the only thing I know right now?
That's how many moles of CO2.
Moles of CO2. So I'm going to plug that in. Alright, different color. Moles of CO2. This is where Juliet starts to get a little frustrated.
It's the whole thing, actually.
I know moles of CO2. How do I get from moles of CO2 to moles of copper oxide?
You see how many moles of CO2 are in, or how many moles
Look
of,
at your
of
balanced
copper
equation.
oxide, so you
I like that. I like both of those, what you said. Look at the balanced equation. So that, when you say, when somebody tells me, look at my balanced equation, that tells me, use the mole ratio. I see it.
2 to 2.
Whoa.
Actually, it's a 1 to 2.
Hold on, let me finish writing this.
CO2, so yeah.
Copper oxide to
I don't
moles.
understand what you look at. I just thought it was the first number.
So I'm trying to
What
get
the hell
from,
am I looking at here?
let Help.
How do I know this?
So,
We
Well,
don't know
there's
this.
three C's.
may I answer
and
all of your
so
questions
it's
Yeah.
1 to 2.
without being interrupted?
Because we're
You may.
looking for, yeah.
Then you understand what's happening, but
Go
let me
ahead. No.
explain. Okay, so we solved for an amount of moles of carbon dioxide of gas. Okay, but what it's asking is how many grams of copper oxide reacted if that's how many moles of carbon dioxide were produced. So we've got to look at the balanced equation because we know through stoichiometry that if 2 copper oxides react with 1 carbon, then 2 coppers and 1 carbon dioxide is produced. So what do I put in here?
2 to 1.
I agree with
How
her.
do you know
I think
that?
you said, because this tells me moles, 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 moles. 1, if it's not there, it's a 1.
Well, yeah, but why wouldn't? Okay.
So I'm just going to take 1 second to tell you guys. Do you guys remember the video where I talked about stoichiometry and I made a green bean casserole?
Oh,
Yes.
yeah, that looked
Okay.
delicious.
I know, it is delightful. But you need 1 can of green beans and 1 can of cream of mushroom soup and 2 cans of French onions to make 1 green bean casserole. It's the same concept. You need a certain number of things to make a certain number of other things. I need 100 chocolate chip cookies, a cup of flour, and whatever else to make 10 chocolate chip cookies.
Wait, you just said 100 chocolate
We can do another stoichiometry problem if you need it.
Let's finish this one first.
But let's finish this one. So, what cancels Juliet in this?
Well, you see the moles, and then the CO2.
Alright, so we've officially gotten from CO2 to copper oxide. But what is the question asking us?
Grams.
Of what?
Cu2 of CO.
CuO, copper oxide. So we're good on copper oxide. But we're asking for grams.
Not moles.
So we want to know, in 1 mole of copper oxide, what is its formula weight?
I'm looking that up.
I got it. Copper, where are you? 63.5 plus 16.
How are we supposed to know that?
You need the periodic table.
79.
79. 0.5. 79. Okay, what? Juliet, what cancels now?
0.
Okay.
And then we left with moles cancel.
And so,
left with grams of CO.
was that what the question was asking the whole time?
Yes.
Yeah.
That's incredible.
Oh my
Wait,
gosh.
here's again?
Alright, let's plug in the math. 0.0012 times 2 times 79 gives me 0.19 grams.